खिल जावा इतनी सी है दिल की आरज़ू तेरी नदियों में बह जावा तेरे खेतों में लहरावा दिल की आरज़ू सोच भरे कलहान मेरी चाह झूमक भंगड़ा पा न सका आबाद रहे वो गाँव मेरा चाह लौट के वापस जा न सका ओ बतनावे मेरे बतनावे तेरा मेरा प्यार निराला था कुर्बान हुआ तेरे अजमत पे मैं कितना नसीब वाला था तेरी मिट्टी में मिल जावा गुल बन के मैं खिल जावा इतनी सी है दिल की आरज़ू तेरी नदियों में बह जावा तेरी खेतों में लहरावा इतनी सी है दिल की आरज़ू ओ हेर मेरे तू हंसते रहे तेरी आंखें खरी भर नम नाम मैं मरता था जिस मुकड़े पे कभी उसका उजाला कम ना हो हाँ माई मेरी क्या फिक्र तुझे क्यों आँख से दरिया बहता है तू कैसी थी तेरा चांद हूँ मैं और चांद हमेशा रहता है तेरी मिट्टी में मिल जावा गुल बन के मैं खिल जावा इतनी सी है दिल की आरज़ू तेरी नदियों में बह जावा तेरी फसलों में लहरावा इतनी सी है दिल की आरज़ू ये तेरी
बनाओ पढ़ो ना तदर ना
Thank you, Anthony. It was a nice song. So thank you, Anthony. So,
welcome ma'am.
sir, namaskar. Sir, namaskar.
Namaskar, madam.
Namaskar. So we'll start our program. I request, welcome sir to the second session of 4th day's FDP program. And I would like to request Archie to give an introduction of Professor Durga Prasad Mohapatra. Now over to Archie.
Good morning, everyone. Respected resource person, Professor Durga Prasad Mohapatra. We are very happy to have you. Let me give a brief introduction about our resource person for the second session. He will be delivering a lecture on malware detection using machine learning techniques. Currently, he is working as a professor in NIT Rourkela. He completed his ME from REC Rourkela and then his PhD from IIT Kharagpur in the year 2000 and 2005 respectively. He has received several academic awards such as Sandeep Mohapatra Memorial Award for Outstanding Research and Bharat Shiksha Ratan Award for Outstanding Contribution in Education. He also received the Maharashtra State National Award for Outstanding Research in the year 2010, Sir K. Amu Murugam National Award for Innovative Research, and Narayan Mishra Award in ICT, and also the Young Scientist Award for the year 2006. He has successfully completed a number of research projects from various funding agencies in India, and he's a senior member of IEEE. He's a fellow for Institution of Engineers, and he's a life member of CSI and also a life member of Orissa Bigyan Academy. So we are very grateful for your presence here. Now I give the time. The next hour is yours. Thank you.
Okay, thank you very much, madam, for your kind introduction. So I don't know whether I am a right person in this FTV or not. I have tried to align the talk in line with this theme of the FTV. Let's see. So, madam, can I share my screen now?
Yes, sir, you can.
Directly result follow go I joined
Screen.
NIC Kohima 4 years to be here. NIC computer programmer NIC Central Department of now our connection is to NIC internet connection here. Balasi
So whether the screen is visible, anyone can.
Sir, visible, and you are also audible.
Okay, thank you. Thank you very much, madam.
Thank you.
So, good afternoon to all. So, standing between the lunch. So, still then, let's try to spend 1 hour on a recent topic. Nowadays, all of us, we are using either desktops, laptops, or the mobile phones, and several attackers are there trying to attack our systems. There are several malwares. So, how we can detect the malwares both in these maybe in the Windows operating system or Android operating system or I operating system, Macintosh, whatever that, how we can do those things. Let's try to see something. So myself and my PhD student Pushkar Kishore, they are working on this particular topic. We'll highlight something, and this is a very interesting area. If some of you want to work in this area, also can continue. Okay, so let's try to start on this topic: how the malwares can be detected using different machine learning and deep learning techniques. Okay, malware detection using machine learning techniques. So before going to this malware detection on the processes or what existing processes are there, what we have proposed, let's first see about the statistics given by this AV class test about these malwares. So according to AV test, since 2008 till now, more than 1 billion malware samples were already released into the market. See the number, the value. And since 2008 till now, more than 221 million potentially unwanted applications, they are already released in the market, and they are just trying to attack our system. In the last 14 to 15, not days, because this is a little bit old data, it may be 2-3 months. In the last 2-3 months, you can see more than 3 million or more than 4 million new malicious samples were already introduced. See how fast they are growing. If you take the example of the year 2022, in 2022, in this year, more than 97 million malicious samples were already introduced. See how much, what is the volume, what is the size. And this we have already shown the statistics from we have shown 2008 to 2022 graphically. See how they are actually what introduced into the market, and how we are being affected by the presence of them. Now let's see what is a malware. What is a malware? How does the name come from? So malware, it is nothing but just a malicious software. From that malicious, the word malware has come. So malware means malicious software, undesirable software. We do not require them. So it is any kind of software that is specifically designed for what? To disrupt or to damage or to gain unauthorized access to a computer system or a network or a maybe mobile network also. So the malwares, they are constantly evolving, and they present significant threats to the computer systems, to the mobile systems, etc. they do what? They force the security analyst to keep pace by improving cyber defenses. So all the security analysts who are there working hard for us for keeping secured our systems. So these malwares, they force the security analysts to keep pace by improving the cyber defenses, the cyber defense mechanisms. The malware detection process can be automated. We'll see two important terms here, that the malware detection systems and malware classification systems. So the automated malware detection versus classification, let's see what is the difference. The malware detection systems, they predict whether an executable file is a malware or benign, not malware. Okay. So detection systems only they will do binary options. The output will be only 1 or 0. 1 means it is a malware, 2 means 0 means it's a benign. But if it is a malware, we have to know what type of malware it is. It belongs to which class, it belongs to which category. So there is another kind of system called as malware classification system. These malware classification systems, they predict the type of the executable. It predicts the malware type of an executable. And here the output can be anything 1 to n, where n represents the number of different malware families. Okay. So now the malware classification systems, they differentiate what? The malware classification systems differentiate between the different kinds of malware. Some common types of malware you can consider as virus, adware, trojans, etc. So these malware classification systems differentiate between the different kinds of malware in order to provide a better understanding of their capabilities. We must know, because all the malwares, they are not of same capable, they are not same dangerous, their impact is not same. We have to know what is their capability, which malware, how it can harm, make or bring harm to us. So in order to know the capabilities of the different malwares, we should know about the malware classification systems. So the malware classification system, they differentiate between the different kinds of malware in order to provide a thorough understanding, better understanding of their capabilities. So I have already given some examples of the malwares. So depending on the purposes, the malwares can be divided into so many categories, such as virus, worm, malware, ransomware, and so on. You know all those things. Only 1-2 examples I can take up. Virus means what? So very often we know all those things, but their definitions a little bit we may forget. So that's why I've given some definitions and examples. For example, virus, it will attach itself to a program and try to infect the device. It will try to infect a device. This is the nature of virus. Whereas worm, what it does, just like our worm in our biology, it self-replicates and propagates the copies of itself to what? To other devices over a network and try to put in trouble and try to infect that one. So this is what is worm. Similarly, we are running out of time. Other definitions I have given: adware, ransomware, backdoor, Trojan, bot, keyloggers, rootkit, logic bomb, and so on. Logic bomb, as its name suggests, it explodes when a condition occurs. So when that specific condition will occur, automatically it will explode. So these are the different types of the malwares along with their purposes. I request you please you should know these things, because this is in our everyday life we have to come across with these malwares. So we must know their purposes. Now let's see, we have already seen what is malware, what are the types of malwares. Now let's think how to detect them. Let's see how to analyze them. So let's see something on the malware analysis systems. So before going to the malware analysis systems, let's first see what do you mean by malware analysis. Malware analysis, it is a process which involves dissecting the malwares to understand how they work and to determine their functionalities, their origin and their potential impact, how do they affect. So by using the malware analysis, we can dissect the malwares to understand how do they work. We can determine their functionalities, their origin and their potential impact. Malware analysis is very much essential for any infrastructure, particularly any network infrastructure working in the field of cybersecurity. Now let's come to the malware systems. What are the different kinds of malware systems, and these systems can be used for what? Malware analysis systems can be classified into two broad categories. One, static analysis systems. Two, dynamic analysis systems. As its name suggests, static analysis, this is done before execution. We call it as the pre-execution analysis. And what does it do? It processes the malwares without running it. That's why the name is static. We need not want to, or we do not need to run the malware. So the static analysis system, they process the malwares without running them, and it extracts features for malware detection and classification. So even if without running the malwares, it can extract the features for the detection and classification of malware. So this is the static analysis. And what is dynamic analysis? As its name suggests, dynamic. We have to execute the malwares. So that's why it occurs after the execution. We call it as post-execution analysis. It involves running the malware. In this case, we have to execute the malware. It involves running the malware either in a physical environment or in a virtual environment, and then it searches the signs for malicious activities. It looks for what are the symbols, what are the signs for having the malicious activities. So these are the major two types of malware analysis systems. And a third type exists, that is the hybrid system, where we'll combine the features of both static and dynamic analysis techniques, that we call as hybrid analysis systems. So before going to the static analysis system or the dynamic analysis systems, malware analysis systems, we have to first know what is the format of a executable. In case of Windows operating system, we call as a portable executable. Okay. In case of Windows operating systems, we call as a portable executable file format. This is used for the executables. Similarly, for other operating systems such as Linux, Unix, Macintosh, etc., other formats are there. For example, for Linux and Unix, we use executable and linkable formats, whereas for Mac operating systems, Mac operating systems and I operating systems, we use macOS. So most malwares, they target what? They target to attack the Windows operating system. So first, let us pay some attention on these malwares in Windows operating systems. Then I will switch over to other half. I will go for malwares for this Android operating system, which we are everyday using through the mobile phones. So now let's see what is the structure of a portable executable file. A portable executable file consists of a number of headers and sections. See, there are two important components here. You can see header component and section component. So a P file consists of a number of header and sections that infer what are their objective. They infer. So a P file consists of a number of header and sections that inform the Windows operating system how to manage the executable file. So how to manage the executable file, that can be what known from this header and the sections. So the header and sections inform the Windows operating system how to manage the executable file. Now you can see there are several types of additional headers, such as MS-DOS header, P header, that is portable executable header, import export address table, some optional headers, and some section tables. And sections, you see, there are several sections are there for data, code, resource, etc. Relocation, you can see. So this is how the portable executable file format looks like for a Windows operating system. Now let's give a clear structure of this P format. This already I have already told you that the P file header, there are two important components, P file header and P file sections. The header of the P file comprises of some additional headers. I have shown here. The additional headers are MS-DOS header, P header, import export address table, optional headers, and section table, etc. Whereas the various tables and fields, they include the section table and import and export address table, etc. So next is the sections. The sections are either code sections representing the machine instructions, or data sections, which can be used for loading the different variables and constants, or some resource sections for holding the messages. You see, these are the sections: data, this search, this resources, text, and so on. Okay. So basically, the sections are either code sections for machine instructions, or data sections for loading variables and constants, or resource extensions for holding the images. So this is how the portable executable file format it looks like for for Windows operating system. This is the complete structure. The portable executable file format will not go into detail. As you can see, this is the format for a 32-bit portable executable file header. On top, you can see the DOS header, MS DOS header is there on the top, followed by the P header, the portable executable header, that is represented as COFF header, that represents common object file format. Then these are the optional headers, that means the standard COFF fields, Windows specific fields, data directions, these are all optional headers, and followed by at the end section table. And section table already there you can see like various virtual size of raw data, virtual addresses, pointer to raw data. These are the different what you can say sections. So these are the different fields of the section tables. Will not spend more time on this. We are running out of time. The detailed description of the P format for Windows you can find at this given link, that if you want you can see for the detailed description. Now let's we'll come to our actual topic. I have already told you there are two types of malware analysis system: static and dynamic. Let's start with the static one. The static analysis, as I have already told you, it provides information about the functionality of the sample, and it produces what? A set of signature features without running the samples. Here we do not want to run the samples. We need not execute the samples. So now I have already told you that this analysis, static analysis provides information about what? About the functionality of the sample, and it produces a set of signature features. This extracted information you can use to predict whether the given sample is malicious or it is non-malicious, that is benign. All right? The extracted information is used to predict whether the sample is malicious or benign. But there is a disadvantage of this static approach. What is the disadvantage? The obfuscated samples cannot be appropriately analyzed. That means there are some samples they are confusing. They are hiding something. So these types of samples cannot be appropriately analyzed by using static analysis. We have to go for dynamic analysis for the appropriate analysis. So static analysis can include two important things: analyzing the P headers and the sections, and then disassembling the program. So let's see the first one: analyzing P headers and sections. The P header provides information about what? About the different linked libraries and imported exported functions that here I have already shown you. You can see the different libraries and the import export address tables are there. P header provides information about linked libraries and imported exported functions. Information such as the URLs, the domain names, IP addresses, names of the loaded DLLs, DLLs, dynamic linking library, names of loaded DLLs, registry keys, etc. They can be extracted by analyzing the P headers and the sections. But the disadvantage that the search for packed or encrypted code used by the malware developers make the analysis difficult. The malware developers, they are more brilliant than us. They will always try to put in the problem, because now the thieves, they are becoming smarter than the police. So the malware developers, they use some packing or some encrypted coding, and this will make the static analysis process more difficult. Okay, this is the disadvantage of the static analysis also. Search for packed or encrypted code used by malware developers make the analysis difficult. So next is disassembling the program. From what to what? From machine code to assembly code. Here we have to load the executables into a disassembler in order to convert it into an assembly language. Okay, so these are static analysis techniques. Now we have already seen the drawback of static analysis techniques. So now let's see how the drawbacks of the static analysis can be overcome. This can be overcome through dynamic analysis techniques. Okay, so dynamic analysis systems. The dynamic analysis, I have already told you, in this case, we have to execute the sample, we have to execute. We have to execute the sample. So the dynamic analysis technique involves executing the sample and monitoring its behavior. This type of technique, this type of analysis technique is performed when all available static analysis techniques fail. So when you see that we have applied so many static analysis techniques, but we are getting failed, so then we must have to go for using dynamic analysis technique. So this analysis is run in a safe environment or dedicated physical or virtual machines. I have already told you in dynamic analysis we have to execute the samples. So this analysis is run either in a safe environment or in a dedicated physical machine or in a virtual machine. Let's see about the physical machines and the virtual machines. The physical machines are set up on isolated networks to stop malwares from spreading. So here, in this method, we can use what physical machines. The physical machines, the physical computers are set up, or the physical mobile phones are set up on isolated networks to stop malwares from spreading. And the other one is virtual machines. Will not use a physical computer. Just like a virtual operating system will use a virtual machine. The virtual machines, they will emulate the functionality of the physical computer, where the operating system running on the virtual machine is completely isolated from where? From the host operating system. That's why this is the technique name is virtual machines. The virtual machines, they emulate the functionality of the physical computer, where the operating system which runs on the virtual machine, it is completely isolated from the host operating system. The limitation of these virtual machines is that some malwares, they stealth, their malicious behavior, they hide, they keep secret their malicious behavior when they feel the presence of virtual machine. And some of the malwares, when they know that the virtual machine is present, they just hide, they keep secret their malicious behavior because they know there's some virtual machine. So this is the limitation of the virtual machines. Now let's see, go for some examples will go, some physical or virtual environments. I have already told you this dynamic analysis has to be run in a safe environment. One example is sandbox. Sandbox refers to a physical or a virtual environment for running the malicious samples. Okay. Sandbox refers to a physical or virtual environment for running the malicious samples. This sandbox, it isolates what? It isolates the executable samples from where? From other system resources and applications. So sandbox isolates the executable samples from the other system resources as well as the applications. There are many online sandboxes are available where one can submit a sample and can get a behavioral report. That means whether that sample is malware or benign. Just through online you can do. Just like in online, you are just submitting a JPG file and directly getting a PDF file without installing software. So similarly here also, you can directly submit a sample through that online sandboxes, and you can get the behavioral report that whether it is a malicious one or a benign one. And one such popular sandbox you can see in the net is that Cuckoo sandbox. Now we'll come to this the theme of this FDP. Application of ML techniques, how the ML techniques can be used for detection and classification of malwares. ML based systems for malware detection and classification, they use a set of extracted features from the executable files. We have to first take the executable files, then we have to extract a set of features from those executable files. By using those extracted features, we can detect whether some malware, that there are some malwares exist, that some malwares exist or not. If exist, what is this category? So first we have to take the samples, the executables, and extract the features. Then you can apply machine learning techniques to know whether some malwares are detected or not. If malware is detected, what is its class? ML models or deep learning models for malware classification employ a great variety of different features. So first we have to extract the features. The extracted features are used for training the ML model or the DL model. Then we can detect whether malwares are present or not. We can classify that this malware belongs to which class. Based on the inputs used for malware classification, the machine learning based systems can be categorized into two particular categories. One is raw binary classifiers. Second one is feature based classifiers. In a raw binary classifiers, what do we do? We use raw byte content from samples as input features, because in the machine learning what model we have to supply some input features. What will the input feature here? The raw byte content which are extracted from the samples, they are treated as the input features in the first classifier. What is the first type of classifier? Raw binary classifier. But what do you do in feature-based classifier? We use either some static features or some dynamic features as input, and then you decide, you detect the malwares, and then we classify this belongs to which type of malware. Okay. So in raw binary classifier, we use the raw byte content drawn from the samples as input features, whereas in feature-based classifiers, as the name suggests, we extract some features from the samples, maybe using static or dynamic features, and then use these either static or dynamic features as inputs, and then detect the malwares and classify the malwares. These are some of the common features for malware classification. The following figure shows the different static and dynamic features which are commonly used for machine learning based malware classification. The features first can be broadly classified into two categories. I have already told you, static features and dynamic features. On the static features, you can see several features such as strings, bytes engrams, opcode engrams, API function calls, and then entropy based, IMG based, function call graph, control flow graph based, etc. On the dynamic features, we'll see memory and registers usage feature, instruction traces feature, network traffic feature, API call traces feature. So these are different features. We are running out of time. I will take only one feature from static feature and one feature from dynamic. Rest all are there in the slide. You can see yourself. I will also share the slide with the madam, and you can collect that if you are interested in. So in Windows, first we'll see about static features. So in Windows operating system, the static features are extracted how? From either the portable executable or from the assembly language source file. But if we consider Android operating systems, how the static features are extracted? They are extracted from the disassembled APK. Now, various disassembler tools for Windows and Android are available in the net that you can see. Now we'll see the static feature, that the string. What do you mean by string? You know, strings means what? It's a sequence of characters related to what? Related to my URLs, IP addresses, access file paths, registry keys, or some names of modified files by the executive. This is what is represented by the string feature. It is a static feature. It is a sequence of characters related to the URLs or IP addresses or access file paths or registry keys or names of modified files by executive. Then what is a byte engram? Byte engram, it's as its name suggests, byte engrams. It is a sequence of n bytes where in the portable executable header or the assembly language code. What is an engram? An engram is a sequence of n adjacent items present in the sequential data. A larger number of sequences of n bytes, where n may vary from 1 to 8, are used as input features. When we are considering the ML models for the training purpose, we may consider a large number of sequences of n bytes. All right. A large number of sequences of n bytes, where n is ranging from 1 to 8, are used as input features for ML model training. But what is the challenge of using byte engrams? The major challenge is as follows. The challenges include the large number of engrams for each sample. For each sample, there can be a large number of engrams, which often requires reducing the dimensionality of the feature vector. This is the great challenge which lies with byte engrams. We are running out of time. So other features I have already listed, like opcode engrams, etc., API function call. Please, I request that application programming interface API function calls. Please read yourself. You can easily understand. I hope you are all teachers. So similarly, entropy-based features based on the entropy. IMG, that IMG stands for the image-based features. Some examples are given. And function call graph, control flow graph. I hope you have already learned in software engineering while reading this McCabe cyclomatic complexity. You have already seen control program. So these are all the different types of static features. Due to less time, I am skipping those things. Then we will come to dynamic features, which can be used for malware classification. The first dynamic feature you can see in our figure, memory and registers usage. Others are instruction traces, network traffic, and API call traces. I will only consider memory and registers usage. You can read the all other three. Memory and registers usage, as its name suggests, the values are stored in the memory and different registers when during the execution. Okay, so the values which are stored in memory and different registers during the execution can distinguish what? Can distinguish the malicious programs from the benign programs. The researchers, they monitored the memory content and the register values before each invoked API call occurs and as well as after each invoked API call occurs. They will monitor the contents of the memory as well as the register values. They used some similarity scores between the benign files and the malicious files in a training set to train an ML model for detecting the malwares. So next dynamic feature is instruction traces. As its name suggests, instruction traces. This is a sequence of processor instructions. That's why the name is instruction traces. This is the sequence of processor instructions which are called when during the execution of a program. Dynamic instruction traces are more robust. Okay, so than the static instruction traces, you can see dynamic instruction traces are more robust indicators of the program's behavior than the static traces, since compression and encryption can obfuscate code instructions from static analysis. We have already seen the drawback of the static analysis. That's why we have to go for the dynamic analysis. The dynamic instruction traces are more robust indicators of the program's behavior than the static traces, because since compression and encryption, they can obfuscate, they can hide the code instructions from static analysis. So network traffic is easy. We have already discussed API function. Similarly, you can read yourself API call traces. These are all the dynamic features. We are running out of time. We'll go immediately to the next one. So we have seen about details about the malwares for this Windows operating system. Now let's quickly look at the malwares, or how can detect the malwares for the Android operating system. And I will give you an approach what we have proposed along with the results. So let's take the case study Android malware, and how we can detect the Android malwares, how we can classify the Android malwares using machine learning techniques. Nowadays, the number of smartphones, smartwatches, and IoT devices has massively increased over the maybe last 10 years or so. A lot of these devices run on Android operating systems. So these devices normally they use Android operating systems, and you know Android operating system can be easily attacked by the attackers. The malwares can be easily injected. So how we can get rid of this? How we can detect the malwares in case of the Android operating systems? Some examples of Android, some examples of malwares in case of Android are given below. Some examples are Alpha Logger tool. This can detect the keys which are typed on your devices. You are using your mobile phone, but what keys you are typing, so that can be sensed by using what? Alpha Logger tool. So the Alpha Logger tool can detect the keys which are typed on your devices. Then the keys used to do, then that key, once they have detected the key, the attacker can use it to do several suspicious activities. Okay. Then the keys can be used. Then the key is used to do suspicious activities like assessing the personal details, the bank details, breaching privacy, or getting your bank account details and so on, or even if they can take the money from your bank account. Android operating system uses a module that verifies permission requested by applications. Okay, so this Android operating system, it uses a module that verifies the permission which is requested by applications. In case of Android operating system, we'll see there are 4 kinds of malware categories. 4 malware categories are used for attacking the Android operating system based devices. 1, adware. 2, ransomware. 3, scareware. And 4, SMS. To detect malwares, using malware detector, both we can use static and dynamic analysis techniques can be used. I have already told you in static analysis, the applications are analyzed without executing, without running the application, whereas while in dynamic analysis, the applications are executed, they are run in either real environment or in virtual environment, then the malwares can be detected, then the malwares can be classified. So this is our proposed model which we have proposed for detecting the malwares and classifying the malwares. See what we are doing. First we are taking the application, performing static analysis. What is static analysis? I have already told you. We are performing static analysis on the static data set. Then we are using some feature selection techniques and sampling techniques. Finally, we are using the machine learning techniques such as random forest and distance, etc. Then we are getting the output, applications level. There are two outputs I have already told you. One for malicious, 0 for benign. So if the label is benign, no action. Yes, if the output will be yes, it is a benign one. If it is not benign, then it may be again either it can be a malware or still it can be benign. So for that we have to go for dynamic analysis because the static analysis might have been failed. So let's, if it is benign, if the label is 0, that is benign, again you run the application. You run the application or okay, you pass the application through dynamic analysis, then this dynamic analysis will be performed on static as well as dynamic data set. Again we'll use, so now you see I am considering both the static data set as well as the dynamic data set. Then again we have to use machine learning techniques again. So the machine learning techniques such as random forest, distance, etc. will use, and then the output again it can be by benign because this benign was not properly detected in static, it has failed. So either output can be benign or it can be malware. I mean what, 0 or 1. If it is 1, then it is a malware. Then what is its category and what is its family. All right. So this model we have proposed for detecting the Android applications and for detecting the malwares in case of the Android applications and to classify them and to classify the malwares. All right. So whatever I have already told you, we have just we have implemented in the same way. Here the details of the implementations are given so that if somebody wants to replicate it, run it on their own machine, they can do. All experiments are conducted on the CIC and MAL 209 dataset. This is the site where we have got the dataset. You can also download the dataset from this given link. However, the dataset has an imbalanced class distribution. You know what is the balanced class distribution and imbalanced class distribution. The distribution of the benign samples to the malicious samples is 0.74 to 0.26. I mean 74% to 26%. That's why it is imbalanced. Different types of sampling techniques can be used to overcome the imbalanced problems. I will show what sampling techniques we have used. We have used mode, random over, Antigan, and WTOs. Different types of feature selection techniques can be used to reduce the noisy features. So we have used the feature selection techniques such as analysis of variance, AOV, Kendall, and whole optimization. Okay. After applying the sampling and the feature selection, you can use, or we have used here machine learning techniques such as net-based logistic regression, SBC, and random forest. They are applied. We have measured the performance of our approach, our model using metrics such as F1 measure, AUC, MCC, etc. After finding the level of the applications, okay. Now, after finding the level of the applications using static analysis, we have two options. First, the applications can be further subclassified. What is their class? What is its category? Using by using static or dynamic analysis only. Second, we can use a hybrid analysis. Second, the hybrid analysis can be used. I mean, a combination of static and dynamic analysis can be used. So, 4 categories of malwares we have taken in the dataset. I have already told what are the 4. Those ransom and those 4 I have already told you. What are the 4 we have taken here? Forgotten somewhere else. Ransom, etc. 4 techniques. Yes, those the distribution is like this. 24%, 27%, 24%, and 25% of scareware. First, the data sampling techniques are applied to balance the number of samples in the classes. Now, after the sampling, then the feature selection techniques are applied. The different feature selection techniques are AOV, Kendall, and well-optimized techniques are used. Then, after sampling, the feature selection techniques are applied. I have already given the names of the feature techniques that we have used. Then the machine learning techniques are applied, such as random forest, SBC, disadvantage, etc. They are applied to find the static, dynamic, and hybrid analysis performance. All right. Now we'll give some of the results. These are some of the results. Let's see. So this table shows the different malware families are their counts. You see number of families, malware families we have considered along with their counts. This is the static analysis of level detection. We have used this data sampling and smooth, random over, random under, and Tegan. The corresponding feature techniques we have used ANOVA, all features, etc. Well optimization technique. The machine learning technique used is here. We have to consider only random forest here. You see. And the measures are F1 measure, accuracy, AUC, MCC. You can see the best performance we are getting when we are using random forest technique along with the data sampling technique, Tegan, and feature selection technique. Well, you can see the best result we are getting in this case. Similarly, this is the static analysis detection confusion matrix. Only 1% benign applications are misclassified, while 11% malicious applications are misclassified as benign. So the performance, you can see it is better here. Now we'll see static analysis of category classification. The app is in which category? Let's see. We'll measure the performance of this approach. Again, here you can see random forest technique gives best result when this random over data sampling technique is used and the well feature selection technique is used. Then the performance is the best one. Then we'll go to dynamic analysis. Again, we'll see dynamic analysis of category classification. This random forest technique, we have tried with multiple machine learning techniques such as random forest, SBC, and distance, so on. But we have seen that in every case, RF random forest gives the better result. So we have considered random forest technique along with the different data sampling and feature selection techniques. So we have seen that random forest techniques gives better result in case of the dynamic analysis of category classification, while we are using this Tegan data sampling technique and all feature selection technique. So this is the next. We'll go to the hybrid analysis. This is the hybrid analysis malware category classification results. On the hybrid data set, we tried two combinations named Tegan for the data sampling, all feature for feature selection, and random forest. Then random over for data sampling, well for this feature selection and random forest. The best results are obtained from the second case. That means the random over plus well plus RF. The updated highest accuracy is almost 90%. F1 measure is 90%. Area under curve is 96%, and MCC is 80%. Overall MCC it is improved by 2% compared to the MCC obtained by using just static category malware classification. Okay. This is the hybrid analysis detection confusion matrix. Then this static analysis of family classification. Again, we have now we have gone for what? Family classification. So previously we are just going what? This category classification. Now we are going to family classification. It belongs to which family? The malware belongs to which family? Here again, this static analysis of family classification. The random forest technique gives better result when WTS data sampling is used, and the corresponding feature selection technique is all features. And similarly, then we'll see the family classification, dynamic analysis of family classification. Here also random forest gives the best result when it is used with WTS and data sampling technique and all features feature selection technique. Then we'll finally see about hybrid analysis of family classification results. I have already told you. All features plus WTS plus random forest is the most suitable combination. We tried the combination on the hybrid data set, and we obtained the updated accuracy is 83%, F1 measure is 76%, AUC is 94%, and MCC 82%. If we look at the what improvement, overall the MCC improves by 1% compared to the MCC obtained for the static malware family classification. All right. So this is some of the results we have obtained for our hybrid analysis of family classification. This is the performance comparison for binary detection. Okay, this is the performance comparison for binary detection. Our proposed, we have compared with RF, KNN, DT, dysentery, and DNN, deep neural network. Our proposed approach, almost it's getting better result. Only in DNN, the F1 measure is 92%, ours is 91%. Otherwise, in almost all cases, this is almost better. The proposed approach shows better performance than the existing techniques. This is the performance comparison for malware categories. One is for binary detection, another is for malware category classification using different machine learning techniques. And you can see our proposed one almost gets at least similar results than DNN, or it is better. In the proposed one gets AUC of 96%, almost better, and MCC also 88%. This is better, but in this case 91%. Just marginally it is almost the same as DNN. So considering the other two, AUC and MCC, you can say that our proposed approach gives better results in comparison to the existing results. Similarly, this is the performance comparison for malware family classification. Almost the proposed method gives better results. So this is what we have done to detect this malwares and then classify the malwares in this way, that in which family they belong to or which category they belong to. So we have observed that the hybrid analysis performs better than the individual, the independent static and dynamic analysis techniques. For static analysis, combination of T-GAN and whale optimization algorithm yields highest malware and benign detection accuracy. Also, for static analysis, combination of random oversampling and whale optimization algorithm yields the highest malware category classification accuracy. For dynamic analysis, combinations of T-GAN and whale optimization algorithm yields highest malware category classification accuracy. For static and dynamic analysis, both, but the combination of all features and known data sampling yields highest malware family classification accuracy. Out of all machine learning techniques, random forest exhibits the best performance. Now let us come towards some of the future works. If somebody is interested in extending this work, you can see. So hybrid analysis based malware classifier can be designed for Windows, Linux, and Mac operating system. Because we have only, I have shown the case study for Android operating system. If you want, you can perform this for other operating systems such as Windows, Linux, and Mac operating system. Hybrid analysis based malware classifier can be designed for Windows, Linux, and Mac operating system. We have used only machine learning techniques. You can also use deep learning techniques, extreme learning techniques, ensemble techniques. So deep learning techniques, etc., can be applied for malware category and malware family classification. So our data set size may be a little bit less. Data sets with more than 50K samples can be analyzed to make the models generalizable and more robust. Adversarial attacks on the detector and classifier, they can also be studied. What is the effect of the adversarial attacks on the detector and classifier, that can also be studied. Other optimization algorithms can be used to decrease the training time and reduce best hyperparameter selection time, such as ant colony optimization, particle swarm optimization, cuckoo search algorithm, etc. These other optimization algorithms can be used to decrease the training time and reduce the best hyperparameter selection time. A single malware detector can be designed for detecting both Windows and Linux-based executables. If it's possible, you can try to design a single malware which can be used for detecting both Windows and Linux-based executables. So these are few of the future directions I have given, which if you want, you can work on this. So based on this, these are the references from where we have taken. Okay, so few papers we have submitted to journals under revision. So this is something about this malware detection using machine learning techniques. Now, any questions if anybody wants? Madam, handed over to you.
Thank you very much, sir.
Thank you so much, sir. So, any question from student participants?
So one question has come from Jacob that
Yes.
does the proposed model
Yes.
suggest, yeah, it's just let me see, saying that does the proposed model suggest the way of preventing malware? See, no, this our work is based on detecting the malwares, and after detection, whether it is benign or malware. If malware, it is of what type? So now this work, particular work has not taken any way. We have not proposed any technique for preventing the malware. Only we can assess what is its impact. Then you will take remedial actions to what reduce the impact or so. But we have not proposed anything else to prevent the malwares. Jacob sir, is it okay?
Any more questions? Sir, you have applied
Yes.
um, meta-heuristics algorithms
Yes.
combined with other like SPM, random forest, and all of
Yes.
this.
Yes.
So, did you try with deep learning?
Deep learning right now only maybe to little bit extent DNN we have taken, but CNN etc. we have not taken. The research scholar is working on this. So in the our next work we will consider these deep learning technique and external learning techniques. This work
Sir,
not yes madam please.
sir, when you are going to apply deep learning,
Yes.
so do you think meta-heuristic algorithms will play a role before applying DNN, deep neural
Yes, madam,
network,
we
or
can
deep learning, any
use
of the
those
deep learning?
meta-heuristic techniques, and we hope this will give actually better result. When we are combining these meta-heuristic techniques, it's obvious we are thinking that they will give better results.
Okay, sir. That means
But,
meta-heuristics algorithms are their own. Yeah. Okay, sir. Thank you. Thank you so much for a very, I mean, I'd say a nice talk, very informative. And it is one of the hot topic which all of us are facing
yes,
this problem while using different types of working in our system. So detection and classification, once it is done, then we can go for prevention by
yes,
again taking off the research in that particular line. So I think, sir, you
yes.
spent a nice, I mean, 1 hour talk was not sufficient. I think you would
Not
have
possible.
spoken for another 1 hour. So thank you. Anyways,
So, madam,
it's
one
really
question is
nice.
from Kumar Saurabh. He is asking that what is the approach for dynamic malware detection if we want to do it practically? See, Saurabh, whatever we have done, I have explained this test for dynamic malware detection. And the tool what we have developed, that is also we have put in GitHub. So that even if you want, you can re-execute yourself. The data set available, our tool is available. First, you try to execute yourself. Then, if you want, you can also propose new algorithms or you can extend the algorithm. So, you just write me a mail. I will give the link where it is there, and you can go to GitHub. Whatever technique I have told, exactly same thing we have implemented. Put it in GitHub for the for use by other researchers. That you just write me a mail, and I will send you the link. And if any work also you require, also you can contact me. I will help you. I am giving my email ID so that you can send me a mail. I will give the link so that you can directly replicate. You can directly execute this thing. Whatever I have told, because now time is almost up. The next speaker might be there. I will tell you. Just write me a mail. I will explain all the details. I will give the link, or I will send the link to madam. Madam can also share among all.
Sir,
The
I'll do
slides
that.
and the link, etc. I will, madam, the link I will mention in the last slide. I'll send you. You can
Okay,
share
sir.
with the other researchers so that those who want they
Sure,
can
sir.
really they can replay, they can re-execute the approach that is present in the GitHub.
Yes, sir.
Can compare
Yes.
their results.
Thank you. Thank you so much. Achila, would you like to wind up?
Okay, ma'am. On behalf of all the participants, I would like to thank you, sir, for your insightful presentation. We are grateful for the time and effort that you took to share your knowledge and your expertise from your years of research. And your depth of understanding and your ability to present the subject in such an interesting way is very highly appreciated. Thank you so much.
Thank you, madam, for giving me an opportunity here. Thank you very much, madam.
Thank you. Thank you so much, sir.
सब close photo हुई
Okay, namaskar.
दुई बाजी के
Namaskar, sir.